What's up guys, it's Eric from Intelligent Quads coming back at you with another video. This video is going to be a little different format than my previous videos. It's not going to be a tutorial style, it's going to be kind of a voiceover of a project that I did recently. So I want you guys to leave me a comment down below and let me know what you think of this video. Let me know if I should do more of this or if I should go back to the tutorial kind of format. But anyways, in this video, I'm going to be going over how you can train Yolo to recognize whatever object you want it to recognize. And the object I'm going to be using for this video is a landing site. And in a future video, I'm going to be making an autonomous precision landing drone control system. So stay tuned for that. But without further ado, let's get into this video. Alright, so we're going to have to do a couple things in order to train Yolo for the landing zone object. And the first thing we're going to have to do is we're going to have to collect a data set of a bunch of pictures of the landing zone. Then the next thing we're going to have to do is annotate those pictures using a tool. And what we're going to do is we're going to put a bunch of bounding boxes around all the landing zones, and then it's going to generate us a bunch of text files that have the pixel positions of each landing zone. And we'll do that for probably a couple hundred images, and then we can run it through the machine learning algorithm, which is called darknet, and then the detection algorithm, which is called Yolo, will then be able to use what is called weights from the training algorithm to recognize the landing zone object. So what I'm doing right here in the beginning of the video is kind of just looking at this new labeling tool that I've never used before. It's called label image, and I'm kind of just going through the steps on the README and setting it up and getting ready to use that tool. But then I realized that I'm gonna have to generate this data set, so I start setting up the Gazebo simulator that we've been using in the last couple of tutorials, and basically getting that all set up such that I'm like looking at the webcam on the drone. And then I'm basically gonna use this package called ROS, or it's called Image View, and within Image View there is a program called Image Saver. So I just run that while I'm flying the drone, and it's saving just a ton of images right here, which will basically make our data set. And this is what we're going to use to train for the landing zone. Alright, so basically now I'm kind of just going through all the images that were saved, and I'm going to delete all the images that basically just don't have the landing zone in it, or are just too close up to the landing zone to like reasonably be usable and discernible. So then I generate a list of all the images, and I'm kind of going to thin this out because there's about 1,500 images. I really only want like 300, and I'm going to make a little Python script that deletes like a whole bunch of them, and I want to use like the modulus to kind of find to kind of just evenly delete throughout the whole data set. So now you see me just using the label image tool just to put a bunch of bounding boxes around all the different pictures, and I did this for about an hour, and basically every time I press save, it's generating a txt file with the pixel positions of that object. So here I'm taking a look at this different darknet repo, and darknet is the neural net behind Yolo, and I really like this repo because this guy went ahead and like made a bunch of tools for basically judging how good the training session is going and judging like when is best to stop your training. So I'm basically just going through all the steps right now to like set up all the config files such that it'll train, and pathing like where my txt files are, and whatnot. Yeah, so here I'm making a master list of all the different images I want to train on, and basically I did a ls and like piped that to a file, and then I added on the absolute path to all that using Sublime, and that's what's gonna be the list for what Darknet's gonna use to look up all the images to use in the training algorithm. Then I kind of just took a couple images out of the data set, and these are going to be my my validation images. So you don't want to train on all your images such that you can judge how good your training session is going. One of the cool things about this video is that you kind of get to see my workflow and like how I do development. So like right here, I noticed that there's a problem with running this training session. It's seg faulting, which originally I thought, okay, maybe it's just using too much virtual RAM, which virtual RAM is the RAM in your GPU. So I was trying to manipulate the subdivisions and the batch sizes such that it uses less virtual RAM. But after manipulating those numbers, I realized that that wasn't actually the problem. The problem was that I had accidentally deleted one of the pictures in the training list. So I found the missing picture and deleted that out of the training list, and now we've got the training going. So yeah, what I was saying about this specific repo, which isn't the main Darknet repo, this is a different repo, but it has the graph, and basically what you'll see at the end is that this graph basically shows the loss, and what you want to see as the training session goes on is you want the loss to go basically to zero and to like go to steady state. So the longer that this trains, the closer that we're going to get to a best fit. So here I realized that I kind of messed up, because if you also have a validation data set, it'll run checks periodically as it saves out the weights, and it shows how good it's doing. So then I realized, okay, I can run this little script on there to see like how accurate each weight that's saved throughout the training session is, and I want to use the most accurate weight, but not too far into the training session, because the farther you go in the training session, the more overfitting you do. You can do overfitting, and overfitting is when the neural net knows the data so well it can't recognize any other objects besides just the objects in the data set that it trained on. So you kind of want to find that like local minimum where it's really good at recognizing the stuff in the data set, and it's good enough such that it'll recognize other objects that's never seen before. So here you see me just setting up Darknet ROS and getting all the paths correct for the config that I had set up for that training session, and then grabbing the weights from that training session and pathing that into Darknet ROS. And here I'm getting the simulator set up and setting up the landing zone. Now I take off and flying with Darknet, and you see it's recognizing the landing zone and like doing a really good job of it. And so I'm flying that manually, but in the next episode we're going to make an automated control system such that it uses the input from Darknet to automatically precisely land on that landing pad. So can't wait to see you in the next one. Peace out.